Hello everyone, welcome to Codynamics. This is going to be a blockMesh tutorial. We are going to do this geometry and mesh it, whatever you are seeing on the screen using blockMesh. I'm going to use OpenFOAM version 2406, which is a ESA version. So if you are following any ESA version, this should work fine. If you are using any other version like .org, and if there is some syntax error, please check the documentation and sort out the errors. Okay, now let's start with the case setup. So first you will get these files from the GitHub. You will get the link in the description. Please download and put it in any location. Like you can see, I have put this in my custom location. And then what you have to do is, first, if it is a zip file, just extract it. Then if you go inside your system, you will be able to see four files: blockmeshdict.original, control-dict, fvschemes, and fvsolution. So we are going to do only the meshing. There is no case setup or running the simulation. So we are interested only in the blockmeshdict file. But usually it has to be blockmeshdict and not blockmeshdict.original. So what is this file? So when I open this, you will be able to see that this is a very basic template which I have made for myself. So whenever I am making any block mesh, I prefer to use this template, and then I will build the case upon that. So you will also get this template in the case files. You can download and use it. Okay. And since we are not going to run any of the simulation, what is inside the control dict, FE scheme, and FE solution doesn't matter to us. All that matters is that you should have these files. Otherwise, it will not be making the mesh. So it will give some errors. So you must have these files. You can take it from any tutorial. If you go inside constant, there will be nothing, and there is no zero folder because we are not going to do any boundary condition setup. This constant folder is there because the mesh will be stored inside a folder called polymesh. So that's why we have this file. And then we also have the para.foam file, so which is a paraview file. If you don't have it when you download, which will be there, but if it is not there, then what you can do is just right click in this location, open in terminal, open your WSL. If you have not installed OpenFOAM already, I will give the installation link in the description. You can check the tutorial and install it. Okay, now we have these files here. So just check typing ls, then do touch space para.foam. Okay, now that will create the paraview file even if it is not there. Okay, so OpenFOAM will understand only blockmeshdict and not blockmeshdict.original. So we have to copy paste that and create a new blockmeshdict file. So either you can just copy and paste it in the same location, and then just rename it to blockmeshdict without any syntax errors. Either you can do that, or if you are comfortable with the terminal, you can just do cp space system space blockmesh.dict, then system slash blockmeshdict. Just remove the dot original, press enter, and you will be able to see this blockmeshdict copy is created. So cp is copy command. Okay, now double click blockmeshdict, open it in VS Code. Okay, I have opened it in VS Code. Now we can start with our mesh set. So by default, it will be boundary name. So what you can do is initially, maybe just initially, you can keep it under walls. So everything is going to be under walls. And now we have to define the vertices. See, if you understand the syntax properly, we have vertices, we have blocks, because this entire thing is a block, and that's why the name block mesh dict. So we are going to create blocks, and then that is going to be meshed. And we don't have to worry about edges because everything is straight lines here. If there is a curve, then we might have to change edges. I'll make a tutorial about that later. Then the boundary is where we will define the walls, inlet, outlet, front, back, everything else. Okay, now let's go to the vertices. Now we have to type something here, but what do we type? For that, we have to understand certain things with the geometry. Okay, now I will explain the geometry. So if you see here, this height is 4.5 meters. This is 5 meters. This is 2 meters. This is 2 meter and 2 meters as well. So if you see here, the scale is 1, which means it is in meters. If you want to change it to millimeters, then you can keep the same values, but just change the scale to 0.001. Then all the values, dimensioned values, will be multiplied by a factor of 0.001, which will convert it into millimeter. But we are going to keep it as meters right now, so we don't have to worry about it. Now, how block mesh will work is that we will have 8 vertices. Okay, so to create each block, we need 8 vertices. Okay, and then we will have one block, and then we will go on and discretize these blocks to get the mesh. So that is how block mesh works. Okay, but how do we generate something like this, the L angle type of thing, with just one block? Can we really do it with one block? No, we can't really do. So let's understand how many blocks do we need to create this. Okay, I will erase it, and let's draw the same thing in 2D. Okay, this is some approximate, assume it's the same thing in 2D. Now if we split it into two blocks, okay, now what we'll have is this block, this is one block, and this is going to be another block. But when we define the vertices, it will have 8 vertices, so there will be some depth. So assume that this is one and there is a 3D point behind this, so we have 8 vertices, and for this as well we will have 8 vertices, these four, right? This and this. But what will happen to this point? So it will be unhinged, right? It will not have any point in this block to get attached to. So this will not work, this configuration will not work. So can we just change it this way? So we will have this and this for this section, and we would have this, this and this for this section, but this point is no way attached to this block, right? Because it has only 4 vertices, there is no vertex to join it here, so 2 blocks will not work, which means we have to go with something more. So how do we split it? So we can go for 3 blocks. Okay, so for 3 blocks we'll have this section and this section, so that all the point, this block and this block will have a common interface with 2 vertices. This block and this block will have a common interface with these 2 vertices. So this is what we are going to do, and in OpenFOAM terms we are going to create 3 blocks. So let's understand how this block is made. So what I'm going to do is I'm going to block the entire geometry into 3 blocks. This is our first block. Okay, let's go one block at a time, and then we will understand how this works. So to do this in blockMesh direct, we have to define the vertices. So let's take a coordinate system. This is X, this is Y, and this is Z. Okay, so we will define points. So this is going to be our 0th vertex, 1, 2, 3. Then we have our 4, 5, 6 and 7. Just remember these. Okay, now what we are going to do is define the coordinates of these points. So how do we do that? First, let's take 0 comma 0 comma 0 as this point. So 0th one is going to be 0 comma 0 comma 0. Now let's take the point number 1, which is this. If you see here, let's take this block, whatever we have drawn as this one. Okay, this is the block that we are trying to build now. Okay, let's assume that way, and another one is going to be something like this. So this is the block which we are trying to build right now. So which means in the x direction it is 2 meters in length. Okay, so the coordinate of the point number 1 will be 2 comma 0 comma 0. Then coming to the second point, it is increased in y direction. So from point 1, just the y direction is increased. So 2 comma, what is the y? So the overall is said to be 4.5 and this part is said to be 2. So this has to be 2.5. So let's put this as 2.5, sorry, 2.5 comma 0. And coming to the point number 3, it's going to be right above the 0 point. So but only the y-axis is increased to 0 comma 2.5 comma 0. Similarly, if you just extend the same points in the z direction by a factor of 2 meters, we will get 4, 5, 6 and 7, right? So 0 increased in just z direction will give you 4. So we can take the same 0 comma 0 comma 2 because the dimension is 2 meters, you can see here. and then for 5 it will be 2 0 2, and then 2 2.5 comma 2 0 2.5 comma 2. So essentially these are the same points of 0 1 2 3, but we just increase the z direction from 0 to 2. Okay, now we have got this. So based on this we are going to create our block mesh detector. So we have to define all these points. So let's go here, and the syntax is going to be like, just open brackets, okay, and first type the 0th point. So what you have to do is 0, then press tab, then 0, press tab, 0. Okay, we have created the 0th vertex. Then the second point, as you might know, is 2 0 0. So let me put this sideways so it will be easier for us. Okay, and these are the points. So let's type all of these in the same order. Next is 2 0 0. Now it is understanding that this is a C++ file, and so it is showing these colors. It takes time, sometimes. So next is 2 2.5 0, then 0 2.5 0. Then what you can do is just copy this entire thing. Instead of typing everything from scratch again, just paste it and change this to 2. So just change the 0 to 2. Now we have defined 8 vertex points, right? 8 vertices we have defined. Now we have to create this entire thing as a single block, because now it's just points. So how do we do that? To do that, there is a convention in blockMesh Direct that if there are two phases, something like this, okay? These two phases are actually connected this way, right? So when we are defining the points, this is 0 1 2 3, and this is 4 5 6 7. There is a convention that first this phase has to be defined. 0 1 2 3 has to be defined in the counterclockwise, and so this has to be in counterclockwise as well, right? So this is the convention that we are going to follow here as well. I'll erase it. Okay, so if you look at this box, this hex, so 0 1 2 3 4 5 6 7, it is in the same order. So let's just put 0 1. So under hex, 0 1 2 3 4 5 6 7. Now we have defined the 8 points. This is going to create a hex, which is a hexahedral, which means there will be 6 faces. And this is the grading, which is like number of cells you need in each direction. In X how many cells, in Y how many cells, in Z how many cells, it will give here. And this is for grading, which is like a bias. Actually I have made another video. I will put the link in the description. You can understand simple grading from there. Okay, right now we are just going to keep it as one cell. The entire box is going to be just one cell without any discretization. Then later we will discretize when we have all the boxes, all the blocks. Okay, so once you have typed all of these, what you have to do is you have to go here and comment this out. So to comment it, what you have to do is just select all of these plus control plus forward slash, and then it will be able to do this on its own only if it recognizes the file as a C++ file. If it doesn't, then either you can just add the double forward slash manually, or you can just remove it entirely. As of now, then you can copy paste the syntax from the .original file. So right now what I'm going to do is just comment it out because it recognizes it as a C++ file. Save it once, go to your terminal, just ensure that you are in the current location which has constant in the system folder, then type the keyword blockMesh. This will be able to run the entire mesh, and you will know that there are 6 faces and there are 8 points and there is just one cell. Now this is what we actually wanted. So we can go here and open our paraview file. Okay, just click on apply, and you can see that there is one block here. If you go to surface with edges, you cannot see any edge because there is just one cell here. And if you want to see the axis data points, you can just scroll down and turn on this data axis grid, and you can see this. You can see that in X direction there is 2 units, in the Y direction there is 2.5 units, in the Z direction there is 2 units. So this is exactly what we wanted. Now we are going to create the block on top of this. Okay, so to do that we will go here again. Now let's take a different color, maybe blue, and draw the next block. Okay, this will be our next block. Now let's do the numbering. Okay, this is 3, 6. Okay, now we have from 0 to 7. We have to define the next set of points. Let's take this as 8, 9, as 10, and this as 11. Now let's find what are the points. So we have to find for 8 and 9. So that will be extruded in the z direction to produce 10 and 11. So 8 will be, so in x direction there is some offset which is going to be 2 meters. In y direction now it is 4.5 meters in height. So that is what is given in our geometry. The height is 4.5 meters. So come on. And in the z direction it is going to be 0. For 9 there is no offset in x direction. In y direction it is 4.5, and z there is nothing. For 10 you just increase the 8th point by a factor of 2 in the z direction alone, so it will be 2, 4.5 and 2. And for 11 it's going to be 0, 4.5 and 2. Okay, so we have found the vertices for the block 2 as well. Now let's make this. Okay, you just go here and give some space. The space is not mandatory, just to understand that this is a new block. Then you can put 2, 4.50. Next is going to be 0, 4.510, and then it's going to be 2, 4.52. Next is going to be 0, 4.5 and 2. So this is going to be another hex. So what you have to do is just copy this, paste it here, and instead of these points we have to define our actual box hex points. So in this case it is going to be 3, 2, 8, 9, 7, 6, 10, 11. So that is the same order which we have to put in. If you remember this order, 0, 1, 2, 3, 4, 5, 6, 7. Similarly 3, 2, 8, 9, 7, 6, 10, 11. It has to be in the same order. 3, 2, 8, 9, 7, 6, 10 and 11. Now save this file, go to your terminal, run the blockmesh again. If you press the up arrow, it will go to the recent command. Now you can see that there are like 16 points, and there are 2 cells and 12 faces. So that's exactly what we wanted. So you can go here, click on refresh. Okay, there is some error that we have made. Let's understand what mistake we have made. So the error is actually here. I have to put 7 and not 6. So I will save the file, go here and type blockmesh, go here and hit refresh. Yes, now it is fine. If you get errors like this, just check the points that you have made. There might be some mistake, and then ensure that the dimension is correct. Now it is, yes, the height, total height is 4.5, and this is 2 meters in length. So it is correct. Now it's time to make the third block. So we will draw the third block. Okay, now we have to give the name. Let's put 12, 13, 14 and 15. We will find the vertex coordinates as well. 12, 13, 14 and 15. Okay, so we have 12. In x direction it is offset by 5, in y direction it is offset by 2.5, z as 0. Then for 13 it is 5, 4.5 comma 0. If you come to 14, 14 is just 13 extruded in z direction, so it will be 5, 4.5 and 2. 15 is just 12 extruded in z direction, so it is going to be 5, 2.5 and 2. Now let's type the same in our blockmesh dict file. Just give some space and then type the coordinates. Okay, now we type the vertices. Now we have to create the hex box. So this is going to be our third block. Now let's figure out what the convention is. So it will be 2, 12, 13, 8, and then 6, 15, 14, 10. So let's type the same here. 2, 12, 13, and 8. Then it is 6, 15, 14, and 10. Now let's save this file, run the blockmesh, and check if it is giving everything correctly. Go here, give and hit refresh. Yes, now we got the entire block. You can see that the dimensions are correct as well. Now we have 3 cells. This is 1, this is 2, this is 3. In X direction it is 5 meters, then Y it is 4.5, Z direction it is 2. So everything is just as we expected. Now the points definition is over. Now we have to start the meshing process. Okay, to do that, what we have to do is first understand how to discretize this entire thing. Now for convention, let's assume that the X direction, or in any direction for that matter, one unit is 10 cells. Okay, so in this first block in the X direction we have 2 units, so it will be 20 cells. So this is up to you totally. Nobody is going to tell you this is how you have to discretize. If you can even take 30, you can take 35, it doesn't matter. So for simplicity and for kind of aesthetics, I'm going to keep everything as square cells. So I'm taking one unit as 1 unit as 10 cells, so 2 units will be 20 cells. So if you see here, this block is also coming attached to these points, right? So if you just kind of imagine the lines here, the lines in the first block is going to affect the lines in the second block as well. So you have to define the second block as well. So now let's understand why we have to do that. Now let's just say I discretize the first block in X direction as 20. I save the file and run the block mesh. It is going to give the error. It is going to say subdivision mismatch between phase 3 of block 0 and phase 2 of block 1. So we know that this is block 0, this is block 1, and there is a mismatch in the discretization. So in the X direction of second block as well, we have to put the same value. So whatever is there here, it has to be there here as well. Then now if you run the block mesh, it will not give any errors. Go here and hit refresh. You can see that it is now discretized into 20 blocks. Right now we can do the same for the third block X direction as well. Since there is like 3 meters, 3 units of block, we will put 30 here. So 3 times 30. You can even take 40, it doesn't matter. Just do blocks, block mesh, and hit refresh. You will be able to see that the X direction is discretized into cells. Okay, now let's do the same for Y axis. The first block we have 2.5 units, so multiplied by 10 we will have 25. And for the second block it is 2 units, so it's going to be 20. And for the third block it is going to be 20 as well. It's these two are same. So I'll just save this, go here, run the block mesh, and see whether it has been discretized. Yes, it is discretized, you can see. So this Y direction is connected between the block 2 and block 3, so it has to be in the same value. This and this has to be in the same value. Now coming to Z direction, we have 2 units uniformly in everything. So let's just change that 1 to 20 in all of Z. Okay, we'll save this, go here, run the block mesh, hit refresh. You can see that everything is a square cell now, and we have discretized. Now if you want a finer mesh, all you have to do is change all these 20 to some big number. Let's say I'm going to go with 40. I'm just multiplying it by a factor of 2, and rest of the points as well. If I run block mesh, you can see that we have a finer mesh. Okay, so the more number of discretization, the finer will be your cells. Well, just go back to our previous values and I will run the block mesh again. Don't forget to save the files after changing anything, otherwise it will not be effective here. Okay, now we have defined the mesh completely. Now we have to define the boundary names. So let's assume that this face is going to be inlet, this is going to be outlet, and this and this is going to be wall. So this L is going to be front and this L is going to be back. So let's assume that is what we are going to do. Now if you see everything else, everything actually is inside the default faces name because it doesn't have a name right as of now. I will turn off this data access grid. Now what we are going to do is go into our blockmesh dict file, uncomment this or add this from your original file. If you remove this, let's start with the walls. Okay, and now this wall type is not actually patch, it has to be wall. It is a keyword, so type it exactly the same. The walls, it can be anything that you want, but this is a keyword. To save it, in the faces we are going to define the points. So if you see here for the walls, I said this entire thing, this entire thing, and these two are going to be walls. So let's start with this single thing alone as of now, just to understand the syntax. See, this face is actually 0473. It has to be in some order that you have to mention. You can't just put 073 and 4. It has to be cyclic. Okay, so 0374 is fine, 0473 is fine, 7304, anything is fine, but it has to be in the cyclic order. So let's define it that way. It's going to be 0374. That is what I am going to take. I'll just save this and go here, run the block mesh. And now if you see, we have the names as wall. Previously we had only default faces. Now we have a new name called walls, and there is 500 cells assigned to it. So we will go to our para view, hit on refresh. You'll be able to see that this single face is not there in your default faces anymore. Instead, it is there in your walls, right? If you go to default faces, it will not be shown because it is not part of it anymore. Similarly, let's assign this face and the top two faces as well, and let's check it. Go to the next line, then the next face is going to be 7, 3, 9 and 11. 7, 3, 9 and 11. And the top two faces is going to be 9, 8, 10, 11. 9, 8, 10 and 11. The next phase is 8, 13, 14 and 10. Just save this, run block mesh. It's not working. I'll open another one. Okay, now there are more cells in the walls. Go to para view, hit on refresh. As you can see, I have selected default faces. So this is not part of default faces anymore. Instead, it's part of walls. Okay, now let's assign these two phases as well. You can go here and create one more bracket. Now we are going to put 5, 1, 2 and 6, and also 6, 15, 12 and 2. Okay, I hope it is correct. Yes, it worked. So everything else is under default faces because we have not assigned, and these are under walls just like we wanted. Now let's create the inlet and outlet patch. Okay, this is going to be our inlet and this is going to be our outlet. So let's go here, just copy this entire thing, paste it here, change the walls to inlet, and inlet has a type of patch. Inlet and outlet has type patch, and walls has a patch type of wall, obviously. So let's just delete it, put a new bracket. Let's define the inlet. Inlet is going to be 0, 1, 5, 4. Save it. Similarly, we will also create outlet. Since we are familiar with procedure, we don't have to check it every time whether it's working or not. If we do it correctly, it will work. So then the outlet is going to be 15, 12, 13, 14. Save it. Now you can run the block mesh. You can see that inlet and outlet has been created. Go here, refresh. Now those two are not part of default phases anymore. Now check inlet, it's of type patch. You can see, yes, inlet is there. Check outlet, it is also type patch. Yes, it is there. And we have our walls. Yes, now we have 6 more faces. One is inlet, so one is front and one is back. Either you can put all of them into front and back, single name, but that's usually not very good unless you're doing for 2D. But if that is what you want, you can do. But right now what I'm going to do is explain you both. So first let's do front alone. I will copy this, paste it here. Now let's assume that the front and back is going to be symmetry. If it is a wall, keep it as wall, but I'm just going to assume that it's going to be symmetry. So I am putting it as symmetry, and the faces are going to be 4, 5, 6, 7. Next set is 7, 6, 10, 11, 6, 15, 14, and 10. So this is going to be our front. Let's just check it. Front is created. Hit refresh. Is there any change? Go to your default faces. Yes, only back is there. So if you go to front, you will be able to see the front alone. Okay, now let's do the back also. Go to this, type back, and instead of these we are going to do 0, 1, 2, 3, 3, 2, 8, 9. This is going to be 2, 12, 13, and 8. Save it, run blockMesh. Yes, now if you select default faces, there should be nothing inside. Yes, nothing is there in the name default faces. Let's select the group symmetry. We'll be able to see those two are under symmetry. Similarly, if you click on patch back, it will be there, and patch front, it will be there. Okay, so this is how you create front and back separately. Now if you want a single name called front and back, what you have to do is just copy this entire thing or cut, because there shouldn't be duplicates. Just remove this front and copy this entire thing or cut, put it here, and remove this as well. There should not be any duplicates. Save it, and if you run it now, you will see that there is inlet, outlet, walls, and front and back. And if you go here, hit refresh, there will be nothing inside front and back. But if you select front and back, the single patch, there will be things. But why are these names still there? It will not go unless you delete it and open a new paraview. Then it will all be fine. We will have just inlet, yes, and then there is outlet, and then there is walls, and then there is our front and back patch. So now if you want the front and back as walls as well, instead of symmetry you can put as walls, then run it again. Now you will have front and back as a wall instead of symmetry. So it shouldn't be walls, sorry, it will be wall, it's a keyword. Run it. Yes, now front and back will be a wall. So how do we know? We just go to group wall, and we will have everything except the inlet and outlet. If you click surface with edges, you can see that. Now if you want to see a cut section of this, a slice of it, then go to internal mesh, click on this slice, go to Z normal, click on apply. It will show you the lines and all. So to hide that, just uncheck show plane. Okay, now snap onto Z axis. You can change this to surface with edges. It will show it as triangulated. To remove that, just scroll down here and then deselect the triangulated slice, click on apply. Now it will show us hexahedrons. So I hope this video was helpful and you now understand how to do blockMesh on your own. I'll give all the case files in the link as a GitHub link. You can download these and you can try it on your own. If you have any doubts, you can ask me in the comment section. If you want any specific tutorial, you can either ask in the comments or you can DM me on LinkedIn or mail me at codedynamics@gmail.com. See you in another video. Until then, stay subscribed and please share to any of your peers who you think might be benefited from my videos. Thank you.